So, extending from a class is single inheritance. The only way you get multiple inheritance is through interfaces. Has anyone already read and looked at what an interface is between and understand the difference between an interface and what a class is? Anyone have any ideas? No one? All right. So an interface is completely abstract. It has no code in it that shows how something is done, right? When I say code that shows how something is done, it's not implemented. It'll just have a method, like it'll say save person and have a parameter for a person object. But it doesn't have any implemented code around the save person method, okay? An interface is completely abstract. Whereas a class is, when you look at a class, you look at the methods, you can see everything. You can see all of how the code is written, everything about it. So when we talk about inheritance, that gives you the power then to do some pretty interesting things. That means if your class implements, it'll be the keyword, implements a particular interface, that means that your class then has to do what? It has to implement all of the code logic that's specified for those methods in that interface. So if your interface says save person and your class has the keyword implements whatever that interface is, then your class now has to have a method called save person where you write out the code. Okay? All right. I don't want to get too deep into that just yet. We're going to be pulling up some code examples today and working through that. But before we do, go ahead and open up your class and make sure you have Moodle open. I want you to look at what is coming due this week and over the next couple of weeks, okay? All right, give me 1 second here. Do I not have... Okay, give me just a moment here. I'm trying to find these files before we get going. All right. Okay, so this week you're going to be looking at inheritance, polymorphism, abstract classes, interfaces. You're going to look at different attributes of parent classes. You're going to talk a little bit about UML. You need to really pay attention to Chapter 10 in Zybooks, okay? All of the PAs and the CAs there. We also we're going to start talking about Project 3. You guys should have turned in Project 2 yesterday, I think. So you got Project 3 coming up. I think it's like a week or two after spring break. Okay, it's very basic. And then next week is midterm exam 2. Okay? All right, your discussion question for this week, you're actually going to be talking about inheritance, just like you inherit certain attributes from your parents. You're going to be talking about what that means for you. Superclasses, subclasses, and all of that. You're going to use zyBooks for that. You can Google some resources online. Use this as a time to refine what that topic means for you guys. There is a couple of videos here on inheritance. Like I said, this is a complex topic, so I've got 3 different videos that kind of break it down. We also have videos on abstract classes that deals with what an abstract class is, an interface, and the difference between an abstract class and an interface. So make sure you take a look at those as well. And then, of course, with the CAs and PAs this week, you're going to look at what a derived class is, accessing members by derived classes, overriding member methods, object classes, polymorphism, array list of objects, abstract classes, is-a versus has-a. Okay, I know that sounds kind of weird, but it's a way of talking about a class that helps you to understand whether it's related to something or has something. Okay, attributes are things you have. Is-a means it's what you are, right? So if you are a student, right? You are persons. That's a is-a type relationship. Attributes would be like you have a nose, right? So it's the difference in relationship when we talk about classes. And then UML. UML is a modeling language. I believe there are a couple of plugins in IntelliJ that you can download for using UML. It helps you to understand how you map classes out, write the relationships of what they're going to do overall. And then lastly, we'll look at the interfaces. All right, to teach today's lesson, we're going to do it a little bit different. We're going to basically just jump right into IntelliJ and work through some sample programs, okay? Excuse me. What I want you to do is go ahead and open IntelliJ with me. Open IntelliJ with me. We're going to call this week Week 10 examples. And when you get there, let me know. Okay. In the source, go ahead and let's create, we're going to create a person object. Actually, let's create a, let's think about this. Let's create a generic item. Okay. Classes in Java, a lot of times they're used to model real life things. So let's think about a, a grocery store item. what's common among all grocery store items? Okay, not that level of commonness. But like, what is, all items have a what?
Price tag.
Yes, they all do have a price tag. But I was thinking more generic than that. They all have a name, right? You go to the counter and you say, I don't know what this is. And the lady at the counter goes, I don't know what it is either. So we're going to give it to you, right? That's what we would all hope would happen when we go to Joe 10, but it doesn't. All right, so let's just be generic here. We're going to say private item name. These examples, private string item name. These examples are actually coming out of your textbook, but let's just kind of work with what these are for a second. How many, sometimes when you buy something, you might have a quantity of that thing. So we'll just say private int, and we'll call this an item quantity, right? And when we're looking at creating objects in Java, sometimes the best process, the best idea for creating something is to make them final. Meaning that once you create an item, that item's attributes cannot be changed. So the way we would do that is just say private final string, private final int quantity, and you notice right away that this item now, IntelliJ is complaining because you can't have a final thing without a value assigned to it. The way you get around this is you actually create a constructor that sets the item. So we're going to say private, let's see, generic item, final string item name, final int item quantity. Then we're going to use a keyword to reference what's inside this class. What's the keyword I'm going to use? It's not that. It's this. So I'll say this item name equals what? Item name. And this item quantity equals item quantity. Now, what I've done just by setting the code up as I have is I've ensured that once this object is created in memory, its attributes are unchangeable. Yes?
Can the public generic item be underneath the private final int string? Or
Say what again?
can the public class be above the private classes or no?
No, it has, because this piece of code here is actually a constructor, and the constructor has to exist in the class. Okay. Now, from our discussions of making singletons, what is the first thing I would do if I was going to make this a singleton class? Yeah, make a private constructor. And the reason I would do that is I would want the class itself to be instantiated in a static way, right? But we're not doing a singleton here, so we're just doing a regular class. So now I'm going to go ahead and create some setters. I'll use IntelliJ's generators here, and I will create a getter. Excuse me, not setters. I'm going to create some getters for this class. So now, as you can see, I have the generic item, I have the item type, the item quantity, and I've got these values. All right, so let's go over here, and we're going to create a new Java class, and we're going to call this a produce item. Okay? And my produce item let's just say, for the sake of understanding this better, let's just say I have all of these things in here again. And I'm just going to copy this just for being quick. Okay. Now let's say that I've got a produce item. Let's say now I've got, what's another type of item? Produce means it's fresh fruit and things like that, right? What are other items you could buy at the store?
Milk.
Well, not, let's stay away from items you eat. Let's talk about other items you might buy.
Clothes.
Okay. So let's call this a clothing item. And guess what I'm going to do here? I'm going to come over here. I'm going to say public clothing item, and I just pasted all of that in. All right, now hopefully you see some similarity here. I've got a produce item and I've got a clothing item, and these are all the same types of information. Well, let's say now I go and I add, what's another item, another type of item I may buy at the store? What's that? A soap item. What tools will be good, but let's talk about soap in general. What would be the overall type of soap items? What would we call that? I don't know. That's a good, maybe household items. Right. Cleaning items. Okay, that works. Cleaning, let's call it just cleaning supplies. And I'm going to say public cleaning supplies. All right, do you all see a pattern here? What's similar between a produce item, a clothing item, and cleaning supplies? What is similar between all three of those?
You don't have items into an item quantity.
Yeah. But if we're like trying to model out things in a store, we might want all of these types of things, right? So what would be a better way of doing this? Well, we already touched base on it a moment ago, right? We created this generic item. So let's go back into our produce item for a moment. And let's say this extends what? Generic item. All right, so the default constructor available. So what we have to do here, we have to say super final string, let's see, I'm sorry. Super item name and what? Item quantity. And then I don't really need any of this down there, do I? But what's different about something in produce versus something, say, in like a generic item?
Expiration date.
Okay. That's a good one. Private date expiration date. And so then I would probably do a getter for that. And I probably need to include another let's do it like this for readability. So now I'm going to say final what? Final date, expiration date. Below my super, I'll say this, expiration date equals expiration date. This is actually pretty succinct, but now I've added a little bit more detail. And if I go over to my cleaning supplies, well, let's go ahead and extend from my generic item. We know inside of here we're going to have to do super and item name, item quantity. We'll take all this out because we don't need it anymore, right? Yeah. Kind of gives us a little bit more flexibility. What is something about cleaning supplies that's different than a produce item? What do you think? What's that? Yeah. What would be useful, say, at the counter? I don't know, right? We don't know, right? So maybe just this is just good enough. Or maybe we have to say something like private string warning label. Maybe, right? And if we do that, we're going to say private final. And I'm going to come in here. Final string warning label. Did I misspell it? No, I'm just not thinking. Warning label equals warning label. There we go. Go ahead and create a getter for it. All right, so this is one way of handling it. So we get to the clothing items. Let's do it as well. We could say extends from generic item, and for readability's sake, I'm just going to bring these down like that. I'm passing the data to the super item, right? Which is the super item of clothing is what? Remember I said all parents are super, right? All right, so the parent item of the clothing item is what? It's the generic item, right? So I got to pass in, I have to pass in to the super constructor, which is this constructor. So I'm passing in the item name and the item quantity, and then I can get rid of this. And maybe for this one, for clothing, maybe I got a couple of other parameters I need to pass in, like private string size, private string gender, right? Those things, that kind of makes sense with clothing items. So up here, what am I going to do again? Well, let's make these final. So we're forcing all the data to come through the constructor. So I'll come up here and I'll say final string size, final string gender. And then I'm going to say this size equals size, and this gender equals gender. And then down below, I have to add my getters, right? So I'll add the getter for it. Okay. So we have some generic items here. All right. When we're talking about classes, we're deriving some information, right? So a generic item has data members like item name, item quantity, and it has these functions on it. We have the get name and the get quantity. The produce item, it has the same type of things, right? It has a get name, get quantity, but it also has the expiration date. The cleaning supplies, right? Where'd my cursor go? There it is. Cursor plot has the same thing, but it also has the get warning label. All of these are different, but they're deriving data that can be reused, because in our world it makes sense to create our objects that way, right? So we could change this up a little bit. We could actually go to the generic item and we could make this, well, let's come over here and let's create a new Java class. And this time we're going to create something called an interface. Okay? And so this one is going to be, we're going to call it our item cost, or maybe item pricing, I don't know. And for our item pricing, we're just going to set a couple of methods. We're going to say that this has to return a double, and this is going to be get, or let's see, calculate cost, and it's going to take in a price object and a generic item. All right, tell me what you see that doesn't make sense so far.
Price.
Yeah. Why does price not make sense?
hasn't been declared yet.
Yeah, hadn't been declared yet. What's also interesting about this? It's taking what? It takes a generic item, right? And what are some generic items that we have? Yeah, so we have a lot of different items that technically qualify as generic items, right? All right, so let's go ahead and come over here and let's create a new class. And we're going to call this our price class. And we're going to let that one be for a second. Let's create another class, and we're going to call it let's see. We have an item pricing, right? Which is an interface. And it does one thing, right? It calculates the cost and returns the double. It takes the price and it takes the generic item. So let's go back to our price. We're going to call this an interface. Okay? And we're going to give this method, we're going to give it a single method called double get price. Now, some of this may not make sense so far. So let's go back to our generic item, and we're going to implement, okay, going to implement the price. So we're going to say implements price. And when you do that, look at your computer and hover over what it says. Someone tell me what it says.
The class generic item must be either declared abstract or implement abstract method to get price in price.
Okay, so you said a couple of things there. Say one was,
Abstract.
yeah. So what is it saying about this class? We have to make the class either abstract or we have to implement the abstract method. So what is the abstract method that's not implemented at this point? Get price. Yeah. Okay. Now there's a couple of different ways you could do this. You could force the cleaning supplies and force the clothing supplies and force the produce item to implement the abstract method. You could force it. Okay? If we wanted to force it, we would say just make this abstract. Now, this class is fine, right? And if we go over to, say, the produce item, what is it saying when you hover over it? Same thing. Why is it saying the same thing? Because now we're extending from an abstract class. And that abstract class extends from a what? From the interface, the price interface, right? Okay. So why would we might do this? Why might we do this? do we want the generic item? Do we want to set the price of the generic item all the way down at the bottom, or do we want the ability to set the produce item separately than the generic item? Yeah. Because if we set the generic item price, what happens then to all prices?
It goes to that same amount.
Exactly. Clothes will all be the same price. Produce will all be the same price. Right? Just by the way we use that method. So let's do this. Let's go ahead and click on our produce item. You'll see a red light bulb there. And I want you to click Implement Method. It tells you there's the method we have to implement. So we're going to implement it. And what is it saying now?
Override.
So what are we overriding though? We're overriding the interface method that's down below, right? Now, as you all know, we can also override, say, the get item name up here. We could override it, right? We're overriding the get item from the generic item. There's a lot of different things you could do. IntelliJ kind of gives us this little icon set here on the side, and it tells us that it's overriding an object. And here it tells us it's overriding the implementation method. Okay? I'm going to take out the get item here. We'll go back to just overriding the get price. And we're going to add one more value up here. And this is final double price. I'm going to do another one. Final double discount. So let's go down to the price. And what might we do to get the value? Well, we could do this, right? We could just say that it's the price times the discount. But do you see a problem here so far? They don't exist, do they? Yeah. So we're going to go ahead and create two more variables. Private double price, private double. Ooh, you got background music. Discount. All right, so what happens if discount is 0? Yeah, so our method is not making much sense here, right? How do we calculate this then? What might we say? If discount is greater than 0, do something like that, right? Let's create a private a member variable down here. We'll call this double final value. And we'll say final value equals that. All right, so how do we do this though? we know if the discount is a percentage and we multiply percentage times a number, we don't necessarily get the correct value, do we? I took my kids to the store when they were little, and my daughter, she looked at the sign and said, "Whoa, this says it's 15% off." And so she pulled out her calculator and she did the calculation, what she thought was right. 15% times $70. And she goes, "This is great. I'll take it." Went to the cash register and went to ring it up, and it wasn't what she said. So what is our math that we have to do here? It isn't 15% of something, it's 15% and then subtracting it from, right? Okay, so someone give me the math here, what we have to do, the formula.
So price minus parentheses price times discount.
All right, so price minus,
And then parentheses.
okay. You guys understand how that worked? Okay, so now we got the price. So we have to do something. If we look up here at the top, do we still have an error? Oh, we still do. So if discount is greater than that, else what? Return, let's see, else final value equals price, right? And then we return final value. Okay, does that make sense so far? Okay, so let's go to our clothing item. Well, we got to do something, again, very similar, right? Now, this is where it gets complicated. We've kind of backed ourselves into a corner here. So the question is, should a generic item have a relationship or be a relationship? Should a generic item have a price or should it be a price? Think about that. So look at the chain here. Here's the interface. I've kind of done this on purpose because I want you to think about has a relationship versus is a relationship. Should a price be a parent of an item or should it be something an item has? Don't be ashamed. Tell me what you think. Item has, right? It's like me saying, your eye is your parent, right? Your eyeball. It doesn't make sense, right? Because an eyeball can't reproduce, but that's what happens when we're looking at classes and relationships. We have to ask the question, is a relationship as an attribute, something it has, or is this something that it is, right? All right. Some of you are smiling, some of you are still like, this is confusing, right? Okay, so let's keep what we have here. Let's go back to our produce item. Well, actually, let's go back to our generic item. And we don't want to do that, do we? So we're going to take this out. Y'all, just kind of work with me here. You may be getting like, man, I just typed that. Why do I got to take it out again? So just take it out. We're going to change the abstract like that. And over here, we're going to add a final price. Let's think about this. How am I going to assign this? Private final price. Some of you, when you write this code, you're going to see a problem, and I want you to tell me what the problem is you see. It's going to hit you like a lightning bolt, and you're going to be like, wait a minute. I'm just going to comment this out just for a second, this method, okay? Because I want us to think about what we're seeing here when we talk about this. How do we go forward? If we want price, but we have this double in discount, how do we go forward? Let's create a new item. And we're going to call this our produce price. Someone figured it out yet? Implements what? Implements price. And we're going to implement the method. And we're going to put a constructor in here. Now, over here, what did we have? Right? So let's just take that out for a second. Instead, we're going to say final price I'm going to pass that up the chain, right? Let's go to our produce price, and I want you to think about what I'm pasting in here. Actually, whoops, wrong thing. Let's do it right. So I'm going to say this price equals price. This discount equals discount. All right, go back to my produce item. And I'm going to uncomment this code. You can uncomment by highlighting it and then doing the control slash, and it will uncomment, okay? So I'm going to copy this code. I'm going to come back to my produce price, paste that in there. And All right, so does everyone see what I have here? All right, let's go back to my produce item. I'm going to delete this piece of code here. So now we had this deal over here, item pricing. I want y'all to think about what's happening here conceptually. We're taking the price and we're passing that off to a relationship, to an action, right? I'm probably stretching you all a little bit more than I should, but I think this is kind of good because it's the best way I can think to work through polymorphism. Because we're building up to this idea that this polymorphism means many shapes, is what it means, okay? And so in Java, you can have things that have many shapes but are really all of the same thing. So we have attributes, we have prices, and I just made a mistake here in my code because an attribute is not an action, is it? No. You may have eyes, but they also have an action. Right? You have a mouth, but it also has an action. You have ears, but it has an action. So when you're writing your code, you want to delegate the actions as well. Okay? And we started to set that up a moment ago, but I think we kind of went down the wrong path here. So let's look at what we got. We've got a produce item. And a produce item has a price, right? We haven't really set, did I set the price? No. Let's take this out. There we go, so we don't get confused. We have a produce item that has a price because the generic item has a price, right? And here is the produce price. All right, so this is what I want to do. We want to say item pricing, and we want to implement that method, calculate the price. So we have the price, and then we have the action, okay? So really, this is what goes down here, isn't it? So let's take it as we have it. We have a price. We can get the price. Let's see, price, and we can get the price. We have a generic item, and we can get the price. What do you think we need to do? Because we shouldn't have two things. Our design here is a little off. We could just take this and do away with that, right? Because generic item extends what? Generic item implements, I'm sorry, generic item implements what? Look at your code. Tell me what it implements. So if you look at generic item, it has a price, so it doesn't implement it. So we're getting the price from the generic item. Are you guys lost? Yeah? All right, let's talk through what doesn't make sense so far. Let's say that for our intents and purposes here, when we call generic item, we're really calling this if we pass it in. I think I'm confusing everyone, so I'm going to take out the item pricing for right now, okay? Because I don't want to confuse you guys anymore. And we're going to take out this piece, okay? All right, so let's just focus on what we have going on for us. We have a produce item that extends generic item. We got a produce price, and this is that piece. The produce item is we're going to pass it into this produce item here. Let's go over to our clothing item. So that means that we need to create a new class, and we're going to call this our clothing price. Okay. So just like produce price implements price, we're going to have clothing price implement price. Okay. We're going to tell it to implement the method. We have what else do we have in here? We have a cleaning supplies, right? So we're going to go create a new class. Call this cleaning supplies, cleaning supply price. That's going to implement price. Okay. All right. The only item in here that has a full-blown associated price item is the clothing price, right? I mean where'd it go? The produce price, right? Because we have this price discount type thing. Actually, we need to make it realistic, we would modify our produce to have a weight, right? We'd say the produce has a weight and you're weighing it, or a quantity, right? But just for a moment, suspend reality, okay? We're going to come back and address this. Let's go ahead and create a new Java class, and we're going to call this our cash register. Okay? This is going to have a public static void main method. And let's create up here at the a private list of generic items. And this is going to be our cart. This is going to equal a new array list. Okay. You guys are familiar with an array list, right? Do you know what a list is? So a list is the interface that array list implements. So last week we talked about an array list. We also talked about another type of list. Do you remember what it was?
Linked list.
Linked list. And Java's linked list is linked how many ways? You remember? It's 2 ways. It has a link to the record after it and a link to the record before it. But both array list and linked list, they implement the list. So this gives me a lot of flexibility. I can just have a cart and I know all I have.
I found this on the web.
It's my phone talking to me and my watch. It gives me a lot of flexibility because I can just use the methods that the list uses. Okay, so let's go ahead and say cash register equals new cash register, and I'm going to say cash register dot cart add, and I'm going to say a new produce item. Well, what does a produce item take? It takes a what? It takes an item name. Let's do apples. I'm going to bring this down a little bit so we can see it a little bit better. Okay. It also takes, if we look at the produce item, it takes an item, a quantity, an expiration date, and a price. So we're going to say the item. What is our quantity? How many apples do you want? 2. Okay. And what's the other item it takes? An expiration date. I'm going to bring this down as well to make it easier. So the expiration date for this is going to be today. These apples are short-lived. I hope you can eat them before you get them home, right? And then we need to add a new what? You can't add a price because if you add a price, you have to implement it. And you could do it like that. You could implement a price on the fly. And when you do this, this is called an anonymous class. But we've already implemented a price item, right? Which was the item we implemented? It was a new produce item. And the produce takes a double price and a double discount. All right, so how much, Maria, how much are apples going for today? Do you know?
The bag, I don't know single apples, but I usually get the bag. They're usually like $7.99, but probably went up $12.99 a bag.
$12.99. That's about right for Joe 10, right? For 2 apples. All right, so we got that. And then we have to add the, what was the other parameter? The discount. So do we get a discount, anyone, for the apples? No discount?
100%.
How about 15%? That's our discount. All right, so now we've added that to our cart. Let's go and add another one. Cash register, cart, add. What's our next item we're going to add? Let's add a new clothing item. What type of clothing item are we going to add? T-shirt? Thank you. T-shirt it is. And the T-shirt we're adding, it's going to be maybe 2. And the size, let's say large. And what was the last for our clothing item? It's gender, right? Okay, so we're going to say just a male T-shirt, large. Now, we haven't specified a price for this one. So let's go back to our clothing item real quick. And we know that we have to specify price because it's saying that a price should be specified. So let's go ahead and say final double price. And we'll pass in final price. There we go. Okay. That's good. Let's go back to our cash register. I'm going to bring these down a little bit just for readability because it's hard to read when they're IntelliJ puts these pseudo labels out in front, but what happens is it makes it hard to see everything on the screen. So we need to give this a new clothing price. And that's it. Let's go to our clothing price though and just set a price. We'll just say all right, let's do it right. Let's say new constructor double price and this price equals price private final double price. Doable. There we go. And there we go. We have our price. We're not going to do any calculations on it. We're just going to return the price. All right, so we go back to our cash register. And for a large T-shirt, I don't know what T-shirt prices are going for today. 26.99. All right. So now we got the items. So we need to calculate the cost of those items, right? So I'm going to come down here and on my cash register, I'm just going to create a new public double calculate, and this is going to be this is going to take a list of generic items and I'm going to create a double final value equals 0. I'm going to say for generic items. You guys remember how that worked for your for each loop? So we're going to say item get price, and all we're going to do is just say final value equals final value plus get price. What are we missing? There we go. All right. We're almost out of time here. Let's talk about the naming of this. So item is from generic items, and I say get the price. And get price gives me a price object. And on the price object, I have a method called get price. You guys understand how that works? Okay. So I'm just going to loop through all of those. I'm going to return the final value. Okay? So I have my cash register. I'm going to say calculate, and I'm going to pass in the cash register cart. I'm going to give the total, just a simple system out print line, and say what the total is. All right. Let's talk through the code real quick. Does everyone understand what's happening? It scanned you. I think you're running a temperature there, man. All right. Does everyone understand what's happening so far? We've separated out these classes into objects. We have derived classes. We have polymorphism going on. We've got prices that could be different things based on the interfaces. A lot of stuff is going on here. And then we're adding the items to the cart, and we can add a produce item to the cart because a produce item is a what? It's a generic item. And we see that because we've said that our list can hold generic items. We have a produce price which implements what contract? It implements what? The price, right? We have a clothing item that implements the clothing price. And so each of these we're delegating out the functionality. And the produce price has maybe different logic behind it on how it does the calculations compared to a clothing price. And that would be if we went on out and generated the cleaning supplies class, that would as well would have a different method. Okay. Shall we run it? Or how many of you have kept up with me in coding? No? Oh, no. Why not? All right, here we go. We'll just run it and see what happens. All right, so we got an issue. What is our issue? Cleaning supplies. Let's go to cleaning supplies. And what's happening with our cleaning supplies issue? Cleaning supplies class.
There's nothing price.
Yeah, there's no price, right? All right, so let's go ahead and add in the code. We'll say final price equals price, and that's price. That's priceless, right? All right. You know what's nice about handing an interface versus handing an actual class? Because this doesn't really care which class you hand it as long as it implements the contract. And what is the contract of the price interface? That it's going to return a price, right? That's the contract. Okay, so we got all this. Let's go ahead and we'll compile it. Okay, it looks like it all ran fine, compiled fine that time. Let's go back and run it again. And there's our total amount we spent, $38.03. Okay. All right, so when we're talking about, we've talked about so far today derived classes. We've talked about has has a relationship versus is a relationship. We've talked about lists and array lists, okay? And a list is what type of Java class? It's the same type of Java class that a price is, by the way. It's an interface, right? Okay. Think about interfaces like picking up your remote control at home. You have the top of it is the interface. You have all the buttons. You don't really know what's going on underneath. You know that if you just press the button, the TV will turn on. And if you press Netflix, your favorite shows will come up, right? It's just an interface. The actual implementation of the interface is underneath it. So we have classes, we have interfaces, we have this idea of polymorphism. A produce item is a generic item, and a generic item can be a clothing item. It can be a cleaning supply, right? These are all, it's polymorphic. It can take on different shapes. These are the big concepts behind polymorphism: inheritance, interfaces, and so forth. All right, any questions so far? Yes?
Are you able to share your code in GitHub or
Share this code?
have your recorded as it permanent?
I can't hardly hear you, Dan.
Oh, sorry. I was just asking if you can share it, but you have it recorded.
Share what I've typed today? Yeah. Yeah, it's recorded as well, so I'll share that. I'll share both. All right, we have 5 minutes. I want to real quick go over project 3, okay? Just in the last 5 minutes. This is what I want you to do. We're going to create a new project, okay? And we're going to call this, what are we going to call this? What project do we call this? Y'all see it in there? Just call the project a tax return, I guess. Okay? All right. You're going to have 2 classes you're going to use in this. And I'm not requiring you to go all out here with all of these interfaces and so forth. But I am wanting you to think about the is-a-has-a relationship. Okay? So you're going to have a tax return class, and you're also going to have a method called, a class called prepare taxes. So you got 2 classes that you have to use. Okay? If you look at the requirements, I'm going to drag this over here real quick. In the requirements, you're going to create a tax return class, and it holds this information: Social Security number, last name, first name, address, zip code, marital tax liability. Okay? So I'm going to copy that real quick. I'm going to go back into the tax return class. Okay? So that means that we're going to create a private final string SSN, a private final string last name, private final string first name, private final string street address, private final, what else do we have in here? String city, private final string state, private final string zip code, private final string Oh, this is not a string. This is your annual income. So this would be double annual income. Private final string marital status. I misspelled that. Okay. And then the last one is what? Tax liability. Private final string tax liability. And this is probably a double as well. Okay. Based on the fact that I did those all as finals, when you're going to create a constructor, and you're just going to do that. Okay? We'll do it like this so you can read it better. Okay? So you've got all of that, and really the last thing you need to do is generate your getters for this. Okay? So, did I do this in the wrong class? I did. All this is supposed to be in your tax return class. I did it in the wrong class. All of these variables are supposed to be in your tax return. I don't know why I did it in the prepare. I can fix that real quick though. We just copy all of this. This is all supposed to be in the tax return, okay? Because this object represents what a tax return contains. So we'll regenerate the constructor here. There. Okay. Your prepared taxes, let's take this out. Your prepared taxes is where your public static void main method is going to be. This is where you're going to put your private scanner. You guys follow me what I'm doing so far? So down inside of this one, when you say public static void main method, you're going to take the scanner and you're going to say, I'm going to create a new tax return. And that tax return has to contain all of those elements. Okay? So your tax return just holds the data, and then your methods that are going to be used for calculating. So here it's saying the constructor is going to calculate the tax liability for you. So if we come over here to your tax return, we'll have a private method over here. Calculate double calculate liability. And I did you all wrong here. This should not be a part of your constructor. Okay, so you just do that and take the liability out from there. Okay, but inside of here, you'll say this tax liability equals calculate liability. Does that make sense? So that when you come over here and you're finished with your, let's see, this is going to be tax return, Ezra's taxes he owes big time. Okay? And so when you're done with that, you can say, okay, what's Ezra's taxes he owes big time? Well, you could just print the tax liability. All right? Now, the other details that you have to finish are all inside of this. So you use a scanner to populate everything. You got a private method that's calculating it. Okay? This one's actually very simple compared to the last project, right? All right. Guys, that's it for today. If you have any questions, please let me know. I will be around for a few more minutes, and otherwise, I'll see you next week.